Okay, so what I'll do is conclude one or two things that we started in a previous session, and then we can jump back to the workflow. The conversation last time was around trying to understand what happens at a technological platform level, and then what happens at an algorithm level, because there are different pipelines that can be applied at different levels of detail. So we're suggesting two parts to this session. One is I'm just going to take you through some of the architectural configurations that are normally used in this environment. Then Bodhi and Ramsey will lead a conversation around a pipeline, and Bodhi will show one of his pipelines if you've got it running, just to give you an idea as to what it looks like if you had to do this by hand or manually. Because a lot of the pipelining capabilities that you're going to use if you deploy any of the ecosystem components in a cloud environment, you'll probably use the flow tools that are available to you, because we are an adjacent technology to what you already would implement as a generic pipelining environment. If you think of a customer scenario, the customer has a real-time journey and a trigger that they want to source from an external, whatever the source is where it's going to come from, and that will trigger a number of actions. You also have real-time interactions, let's say through an app or a web environment where you want to take the scores that were generated, or you want in real time a model to converge to provide feedback to your user interface. So what happens is you have to decide, is there a static design construct at play or a dynamic design construct? If it's a static design, the UI has already provided the panels, sequences, and placeholders for where you need to place whatever the prediction engine is going to give you as a result. So if you need a place to put a banner, image, or an icon, or whatever the user interface element is, and you already created and place where you're going to put it, this means that when you configure the ecosystem environment, you need to comply with the real estate you have on that user interface. If you use a dynamic user interface, when you call it the backend, it will tell you which panel should appear, and then call it again to tell you what the content of that panel would be. So if you can kind of picture a Netflix scenario or an Instagram scenario or a Spotify or any of your favorite digital channels, firstly, it needs to figure out what the swim lanes are. Then it will figure out what the icons are within each swim lane. And then it needs to figure out what the description is. And it will sequence all of those based on your personal preferences. That is what you see at the top. The journey is called a network configuration. So a network configuration is when you tell a particular scoring engine to go do more work and return a result. This kind of configuration is abstract. It's not telling you exactly where the clusters will be configured. It doesn't tell you where your external data sources will come from. But we normally start here to make sure we have an understanding. If you look at the picture of how we would separate the configuration of how your project gets set up versus the scoring that happens in real time, that is the runtime environment. And that's what you would have seen last week in our last session with the swim lanes that dealt with how you would configure a dynamic, static, or a generative model, how those will be created to be deployed, and eventually you need to make sure that you have it accessible in some form for inference purposes. If you run this on Azure, GCP, AWS, or whatever it might be, those companies already have machine learning pipelines and target environments. At the end of the day, once that's done, even in a cloud environment, it exposes that core capability as an API. In our world, those two lines that you see, the blue lines creating a magnifying view of what we're looking at on the left, is that everything that you access is headless. So that means that the runtime environment, the outputs of whatever comes through the API will be registered in your current API layer, and it will, for the purposes of the people consuming that API, look exactly the same as any of the other APIs that you've configured within your API ecosystem. The idea is that you want to make sure that there's no complexity when you decide on how you access it, what you do with it. And in a moment, I'll talk about the Open API standards. It used to be called Swagger. We support Open API 3.1. You want to understand how the components fit together. And then once you've decided how the components fit together, you then need to decide, in our world, in the ecosystem world, we typically create this as an environment. Let's look at if you had to have a generative stack that you're going to configure, how you would separate the layers conceptually, and then architecturally, you would obviously implement this at a detailed level. But on the far left, you have various touch points. So the touch points would be a Python library or some API gateway that comes straight from either your internal layering mechanism or straight from your visualization tool. If it's a Python library, it could be some kind of facade, or you want to do some additional work before and after you've gotten the score. In our world, you'll set up a project, and that project can become a module that you can then move around. So that means that it comes with all of these assets like we've discussed previously. In this case, you always need the prediction server where most of the work is going to be done. And then you have ecosystem notebooks and ecosystem algorithms that are all of the capabilities that you need to run when things are not necessarily online always. We do have an online Python stack at the moment for MCP, for our Model Context Protocol, and I will demonstrate that in a second, just before I hand over. And then the next thing is that for your chat server, and also for a server that, if you want to set up a server to have private scoring for a generative model, then you would go into that second layer where you have closed language models that can be used within our environment. So you might want to run a language model that is a small language model, especially for your agentic journeys. You don't want to run a large language model. It knows too much. Takes too long. Its latency is too high. You want something that's incredibly quick and can get results back as fast as you need to get your real-time engine to work. Or you might even have in your closed LLM something that connects to the one with the queue where you get 1,200 tokens per second if you want to do something in high speed that you want to control. But in many cases, a lot of the generative models compared to static or dynamic models do not require sub-millisecond or millisecond level response times. If you're having a conversation with a conversational AI, the architecture in the backend would not require that cost and that technical complexity to have that immediate feedback. So that means that if you're going to run OpenAI or AWS or Google with Gemini, or you run Claude with from Anthropic, or you run Llama with whatever model you have installed yourself, it doesn't make a difference if the data does not necessarily have to be secure. If it is something that you got some latency that you can play with, then it's okay. But as soon as that's not the case, then you need to think about things a little bit differently. Because by the time you want to bolt in, let's say, a recommender or a next best action or something that's going to execute very quickly, and you want to bolt that into a conversational journey or into an agentic journey, you need the execution to be incredibly quick. And we'll talk about that shortly. The basis of all the examples I'm going to show you next is a concept that we call permanently in production. So what you want to do, if you think of that bottom line, the client pulse responders, our runtime engine, you want to be able to have infrastructure in production that is pre-tested, pre-connected, got its logging configured, its APIs are registered without a name or a name that you might want to change. But the thing is that you got this production environment with all of your in-production capabilities pre-configured with no scaling turned on yet. Or if you've got scaling turned on, it won't do any work. The moment you want to make changes to your project, or your project has never been productionized, you can then push that configuration, those parameters for that scoring engine into production. You can pick the node that it's going to go to, and that node must scale independently of all other nodes. So let's say that I have a requirement to decide on what a banner is inside an app. Firstly, should the banner appear? Is the banner background color a certain color? What is the text that appears inside there? Then call 3 different environments that are now pre-configured. Each must return its result in 2 to 3 milliseconds, and you then want to be able to bolt that into the front end. And then if you want to build custom work and the like, the bottom track, this means that you can then build that. And we did discuss a little bit of these concepts in our previous session. Okay, let's look at Azure quickly. In an Azure context, very high level, you get your sources of data using your generic pipelines. Those will come in, and you'll make sure that you have a process feed if you use Databricks or Spark or MLflow, whatever that might be. In this case, it uses a medallion architecture. So that means it's got bronze, silver, gold. You can have a Delta Lake store. So that means you can continuously update it to make sure that you deal with the differences. And all of these capabilities are out of the box available in your cloud environments. By the time you want to deploy it, it's called serving. And that is really where we play most of whatever we do. So the top right there is showing machine learning and Azure Kubernetes service. By the time you've got your deployment ready of whatever the scoring is you want to do, and it goes into production, they use Kubernetes for that. And in our case, we will use exactly the same Kubernetes service or a separate cluster, and you'll be able to serve whatever you need to serve through there. On the far left, you can see that from what we discussed last time, you've got Kappa and Lambda-based approaches. So even if you've got a store and forward or a real-time feed, you must decide how you want to deal with your ingestion. We almost always recommend that if you have real-time requirements, make sure that those are all first-class citizens. They all got quality of service configurations set for whatever the throughput is that you require. And that means that in this case, everything up until where you see where it talks about enrich and then the BI premium and then the business user, we basically slot in right at the end of that cycle. So if you want to use our platform to do the configuration, then we slot on top of the architecture. So that means we don't compete with generic pipelines that come from Azure or whatever the platform is. We don't build our own database. We are a vertically oriented company when it comes to AI. We don't want to replace your horizontal capabilities. We connect to your data lake. In this case, it shows Cosmos DB. You connect to your document database for what you need to do. That means that you typically will have a scaffold for your architecture and then slot on top of that as an adjacency. And you provide security access to whatever it is that you want to do. We do have the capability, if you want to run all of this on, let's say, a local server, and you don't want to use any of the cloud services, all of these components we've got in an open source stack that can be deployed on-premise. All the cloud providers offer the same kind of capabilities. You have your data sources, and they typically separate your real-time from your store and forwards, your Kappa Lambda debate, and you will then have to decide what you then do with your data lake. Same story. All of that is typically out of the box across providers. But by the time you start using it and applying your specific approach, things change significantly. Now, if you think about your object store or real-time scoring databases and real-time dashboarding and so on, you normally would have to have a cloud-based configuration that would be out of the box, something that you can set up and run. And the moment you are ready to deploy, you'll see there on point number 10, when you look at your SageMaker, we live in that same block or right next to SageMaker. So that means that you're still going to build your generic offline models in your SageMaker tooling. We don't compete with that platform, but you can run a lot of the static cases, depending on what they are, in our world, because we provide you with predefined algorithms and everything that have already been tested. And that's what we provide updates with continuously over time. In this case, it shows DynamoDB and Lambda. You can configure in the context of a cloud environment. You, again, slot on top of the capabilities that are provided to you. In a Google cloud environment, same scenario, your ingestion of your data comes in. So if it sits in, let's say you've got a service that runs in your Kubernetes environment to get your data in, all of that's the same. So that means your transformations, all the real-time scores, you separate your real-time from your offline, that obviously all the cloud providers recommend you do anyway. And in this case, what will happen is by the time you get to serve the model, that is where you typically will fit most of our runtime capabilities. That means we are heavily focused on model serving, meaning can I score at high speed? Once I've configured it, our configuration can run entirely as an adjacency to your cloud. You don't have to scale your hyperparameter configuration. The user interface and the Python libraries are super lightweight, because by the time you've got it configured and you need to do inference on it, that's when the real compute and the complexity comes in. That's when you need to have all the rules around security and access and everything that is really critical at that stage. So that just means that by the time you configure, like in this case, you've got a set of producers, and those producers are going to tell you what needs to happen next. You have an ingestion pipeline that can be configured all the way through. In this case, what it does a whole lot of work, and it produces an output into Bigtable. So in different clouds, obviously, you would use different environments. So in our world, the runtime will connect to the Bigtable if your runtime feed has already created a sink or enriched the data, or you might slot us into that data shared and data ingestion sink. And that means that you can use us to enrich a data set. So let's say that you have the spend personality implementation and you want the transactions to be categorized and to check the last, let's say, 200 transactions of a customer continuously every time they do a transaction. You can slot it in there, and that means that the destination data set that sits inside the data center can be used for reporting, analytic, or any additional prediction capabilities, then already has a score assigned to it. And typically there's about 14 different values that can be saved. Each one of those can mean something for you to decide on communication. You can refer to our spend personality series and like the one that manages it now as to how that will happen. But yeah, from a business point of view, this is more from a technical standpoint. At a conceptual level, you trigger some actions, do the ingestion, you perform the enrichments, and those enrichments, one of those is what you can use us for. So that means you enrich it with a spend personality, enrich it with a money personality, or an interaction personality, or whatever it might be. You then provide some kind of analytic, and you use Vertex AI for that, so we can bolt into the Vertex environment. You will access us as one of the targets or sources, depending on what you want to use us for, and then eventually you can activate it by whatever the function is. The idea is that you can apply a multitude of different constructs. One thing I haven't really spoken about is that you can either go directly from source to target or go through an interim layer. So what I'll show you by example is that if you look at the MCP server, the Model Context Protocol, imagine you have on your architecture an existing endpoint that is exposed through some URL, whatever that URL is, in your private environment or in the public, depending on what you want to do with it. The background architecture, obviously in most cases or in all cases, completely isolated from the person using it. In this case, you want to map or have an ability for public agent tools to access your MCP server. So this MCP configuration contains a number of APIs that you want to then access in another product. So if we go to here to Claude, and I want to do a setup or a configuration, there is some arguments for this particular connection. I'm connecting it to an MCP server, and it shows me that I'm connecting it to HTTPS MCP ecosystem, and that's the one I just showed you. Once this has been integrated, and I then want to go back to my chats, what I can do is pick a chat or create a new chat. Let's just do this. Let's just go create new chat, and you'll see that the moment you click on the tools button, there's the runtime offers, and this is directly provided from ecosystem. So that means that you can integrate, in this example, the front end directly to the back end. You don't have to worry about anything in the middle, depending on the configuration. You can configure network to include rules and whatever it is, and guardrails and other capabilities that will help you for this thing to then perform what it's supposed to perform. So how it integrates in the context of MCP, if I ask it, in this case, well, refresh the runtime for me. How does it know the runtime? Because that is its name here. It knows that the refresh capability has been turned on and not off. And when you then ask it to do work for you, the intent detection engine will pick up what the intent is and then execute it. If you think about the configuration, the load of the chat and all of that work happens on the front end. The back end is a two-layer architecture. First layer is the interface with the chat server, and the second layer talks to your large language model behind the scenes. So here, this tells you that it's got a refresh, and I'm going to call runtime config. It should detect it off. Made a mistake. So now it's going to call my config, and now you see that it's going to take a payload that comes back and present it to me. This is what a payload would look like. You'll see here that the parameters that it passed in and the result is all in a JSON environment, and your MCP server, and that's what generative models are really good at, to format a lot of these kind of standards. Okay, so that's just an example as to how you then can connect to these different environments. What I thought I'll do is hand over to Bodhi or Ramsey, who's going to go next, and maybe just talk through how some of these pipelines can be configured if you had to do it in your own environment.
Yeah, I'll maybe just show a quick demonstration of how our Python wrapper stack works. Just share my screen quickly. So this is going to be primarily for when you want to productionize your use cases, especially when you have requirements around daily retraining. If you have a period of time you want to particularly do something, then you'll have some kind of pipeline software set up like Airflow. So to access these things, API endpoints directly through Python is a possibility, but just to make it easier, large sets of wrappers allow you to access all the ecosystem functionality through Python. Python is easy to use, and most people will be able to set up the code required to do whatever you need. So I'll take you through this file. This notebook over here will show you the basics of setting up a recommender and testing it. When you are at the point of productionizing, you won't be building it from scratch. You will be potentially just editing small things in place and just putting new data and making sure that the thing that you want to do, you want to start from scratch. So there's a lot of text in here. I won't take too much time on that. I'll just talk to it. The important part around the wrappers, as I talked about it, like these are just standard Python package, not going to be interested in talking to you about now. The two core sets of function that you want to talk to is the prediction server, which we call here just prediction, and then the runtime server. And I should note also that these wrappers are publicly available. If you can install it via pub, it's all available. But obviously, if you don't have an ecosystem server running somewhere, you can't do anything with it. Just be completely pointless code. But we have above the runtime and the predictions, we separated out the functionality into distinct groupings like data management, HDO workers, prediction agents. These are groupings to understand what type of functionality you can access in that package. The first thing you're going to do for both the runtime and the prediction server is to log in some way. So all these credentials are bogus credentials, but you'll just set up some pointed to wherever your server is set up or whatever security credentials you have set up and get an authentication token. This is going to be key because without this authentication token, every function will require you to have the authentication token pass through to it. So the first thing you can do is just look at your projects or find the project that you're interested in. Also add new projects. This query over here just calls this endpoint with that authentication token over there and just brings back all the projects you have. And you can look through them, sort them, find the ones you're interested in. Then there's also the process for adding a new one. It's straightforward in a sense, and it's just a lot of fields that you have to fill out, but you're not as interested in that because in pipelining you probably won't be creating new projects on the fly. And then, you can just save it at that point. And you can also edit your projects in place if that is something that you want to do. Then the part that's probably more important is when you are trying to do a daily or a weekly pipeline is to refresh your data in some way. There are multiple ways to ingest data into your environment. The more robust way will probably be through some kind of Presto interface, but you can also just upload raw files if that is how the data is presented to the ecosystem environment. There's ways to draw CSV or JSON files, or you can set up a Presto connector and just ingest that data directly, or for certain use cases, you can also, instead of ingesting the data to the local DB, which is a data format we prefer to use in the ecosystem environment, you can set up a Presto connector to directly read that data at the point of scoring and running. But yeah, you can see over here, you set up just a connection strings for this Presto, just tell it get the Presto. Or if you want to duplicate the data into the Mongo, you will make a SQL query like this. And it's important to mention for those who are not familiar, Presto is just a data virtualization platform, and it allows you to connect to any data storage software using a standardized querying language. You can code one single query and point it to any data server, and it will fetch the same data, assuming the data it's fetching is the same, but it's agnostic to the data source. So you just integrate with Presto. Presto will then be able to fetch data, which is very nice. Once you have your data, you will want to run all your enrichment stuff that you have set up. This isn't shown in this case. It's just assuming that the data is already in the right format with all the enrichments and feature creation stuff already done. Once your data is primed and ready to be served to your model that you want to start training on, you will need to create your feature store. This is just a bunch of functions. To go through them one by one is a bit onerous. So it won't take too much time, but you can essentially over here, it's just exporting all of the data from some location and then ingesting it into the feature store. And once we have that feature stored, the data is now in a format that we can serve to our model training engine. So we internally use H2O, but you can also use PyTorch, TensorFlow. There's a bunch of other we also support, but our go-to is H2O. So that's why you see at the top, like the H2O worker imported and not any of the other workers imported. Once there, we can look at our predictions. This is the point where we are training models, setting up predictors to create models that we can then serve through our runtimes. So you can set up a bunch of hyperparameters over here. The first thing we're doing is just getting some kind of predictor. If we haven't found one yet, then we can create training and validation sets. That's usually a good idea, but it's just a safe thing. Then we create our predictors. This splitting is just a feature store we created before. You can just do a 20 split the training and validation set. Then we get to our prediction. This is now a point where it looks a bit scary because it looks like there's a lot of data to fill in. But this is just all the parameters you want to specify for your particular model. Once again, I'm not going to go through all of this. If you want to know the specifics, you can read the documentation for that particular modeling software. This is particularly for H2O. You can see here we're using the AutoML algorithm, which is a nice way to shotgun approach it, to train a bunch of different models and see which one performs the best. We'll have a bunch of hyperparameters set up here. But once you have that, you save your prediction engine. The key thing is to note is you have to set that up to ingest the frame over here, which is going to be the feature store that we generated earlier. You know that's the training data, and then just the response column, so things you want to target and things like that. Once we have that, we just train the model. We have all the information about how to build this model, and we just tell it to train it. That is depending on the complexity of your training data, can take very long or very short, but that particular train model call is asynchronous, so that's just going to chill in the background and do its thing until it's finished or until your in time. So you can also specify like a max runtime over here, standard thing. So what's important to note is that all of the models that you train are ephemeral, so they will, if the server kind of crashes or shuts down, they will not stick around. That is also a good thing because they can get quite large in size. If you found a model that performs well and you want to maintain it, you just have to save it. This is just the kind of process for doing that. Essentially just tell it and give it some data around timestamps and things. When it was saved, give a name to it. Very easy. So now we have a model. Perfect. Now we need to get this model into a runtime. The next step we want to do is set up a deployment. This is our core structure for configuring a runtime. When you set up a deployment, you will have all the information you need to configure your runtime. You can take that information and push it to a runtime or a new containerized runtime that will have all that configured data in there. As we look at all the deployments you already have. And then here is more configuration data that you need to provide if you want to create a new deployment. You can see there's a lot of information you can add in here. The main thing is not to be scared. Usually our kind of go-to way to set these things up is go build it first on the workbench, because a lot more intuitive and kind of GUI-based approach to understand what you can and can't do. And that will generate a JSON when you have it kind of finalized. And you can just export that JSON into your pipelining environment and have the deployment JSON perfectly set up the way you want. And then if you need to make dynamic changes in your pipeline, you can just swap out things as required. And this is the code to save this prediction. Then there's more code showing how to change a deployment in place. So it just does the same thing. It looks up the project, looks all the deployments that are available under that project, and then find a particular one you want. I think all this particular set of code does is just changes the deployment version of this project. I don't think it looks for a particular deployment. It just finds all the deployments that have the version 0.001 and changes it to 0.002. So something you can do if you want to iterate your versions of each deployment. Now you have a deployment configured, but it's not yet set up to be able to talk to a runtime. So to do that, you will need to, there's two avenues you can follow. If you have a runtime already set up somewhere and you just want to push the configuration to it, you can do that. Or you can alternatively run a build process where you have to have set up a route to a build environment, something like a Jenkins. And it will then take all this configuration data and build you a new container that will have all the configurations of that runtime built into it, and you can then serve that to Kubernetes such that they are able to replicate that and set it up in a way where you can have all your horizontal scaling required for your particular use case. Yeah, so this first step, the first thing you got to do in both of those cases is just to build the runtime or generate the runtime. This compiles all of the information around the deployment, all the JSON data that you need into one single place. You have that available. Now that you have that JSON file, you can now either build it, so this is just the code to build it, or you can push it to an existing runtime. Both of them are served different purposes. The push obviously is almost instantaneous. It just sends a payload to an existing runtime, and it is immediately set up to do exactly what you need it to do, and it's available. Where the build process, it will need to go through a hefty period of pulling all the required packages and make everything from scratch, which can take some time, but it just depends on your use case and how you want to do it. Now we have either, like I said, we built our system or we have pushed it. Now we want to just see does this thing do what we want. We want to send some kind of call to it. So it's pretty straightforward. Now, all of the previous stuff we've done have all been doing on the prediction server, well, apart from the pushing the configuration to the runtime. But now we want to talk to our runtime. So we're just setting up our authentication here to our runtime. And this is where our runtime is located. And we're just sending it a very easy call, telling it, whatever we configured on you now, it's going to do something. It's going to require some kind of call to it, and it will give me some kind of recommendation or offer back. In this case, we're saying, just give me 4 offers. There's no particular params or settings here. We're doing it for this customer. So we're saying this customer is coming in, give me 4 offers with the recommender set up there. You're going to get it back and see what the value is. So I skimmed now through quite a bit here, and there's a lot more functionality available here. So we have a complete list of all the APIs that you can access through here. But if you guys want to see that, we can just look at our documentation. It's all available there.
For the cloud, this Python code can go into your Lambda functions if you want to make it serverless. Mm-hmm. And what will happen is that if you then configure it, like Ramsey was saying earlier, the configuration files you can put straight to GitLab or GitHub or one of your repos. And that means you can completely integrate this. This is just a great way to see the entire sequence fits together.
Yeah. So we have a bunch of these notebooks where we just show like a particular use case. This particular use case is just like how to deploy a recommender.
I think Ramsey
was all the functionality around it.
What people might find interesting, maybe talk about if somebody had to create a multi-model recommender and they wanted to create a model per product, what that looks like. Maybe just talk through the scale of a pipeline like this and what goes into it.
Yeah, this is something I actually did for a use case for a client a while back, where instead of building a single model that will give you a recommendation, I think it gave better outputs, but it made more sense to build a model per product. And I think we had something like 50 odd products, if not more, I don't remember the exact number now. And the thing is, you can configure each individual one of those on the workbench. And that's going to be onerous, but it's doable. But the issue we also had is that that list of products differed over time. So then you would have to go manually and but each time you have updated your list of models, you will then have to go do a difference and see, okay, this offer was taken out, that one came in, do this, do that. So what we ended up doing is we built one default deployment that had all the configurations we know we want to have around there, and then use the pipeline like this to make micro changes to the deployments as required. The big change would be target output being this particular product instead of that, and segmenting the data to be for that particular product. So just all the source data was the same. It was like the data was slightly more segmented and small tweaks were made to each individual products, the feature store and deployment hyperparameter configuration stuff. So it allowed us to be able to do that without breaking your back each week. I think we ran that each week. So it might seem like a lot of work if you can just do it through the workbench, but it's definitely cases where you want to do pipelining like this because it's going to save you a hell of a lot of time. I can't imagine how anybody would be able to maintain the project of that size without robust pipelining in there.
Isn't that exactly the point? That what you want to do is decide what the threshold is, because I find that it's easy to test it in the no-code environments, but as soon as you go to the second or the third or the fifth round of updating it, you then automate. That's kind of, I think, what DevOps and AIOps and everybody is trying to solve for. But the big thing is that maximum flexibility is a story. Is to say that you want to have access to the individual components and decide based on the product how you want to use those. Our notebooks are great examples of providing an end-to-end journey that can be used, and it doesn't matter how it gets configured. So even if you generate 700 models a night, I got an update recently from that same client, Ramsey, and they were running it daily, generating hundreds of models. You train two kinds of models. One model that helps you to select the model that must be used, even though the product is there. So you predict which product from one recommender, then you score it again, so that the second wave will give you a better view of the importance of that product in its own right, because it's scored on the same data. I think that, because there were mixed results. If you got a lot of evidence and you want to use a static model, it means you've got stable transactions and evidence of interaction. But as soon as you go dynamic, the model will converge better from what we've seen. That means you then simplify your pipeline enormously. So I think in one of the future tech sessions, we should talk about the difference between the dynamic and static models and what those mean when you make a decision. A bit like we discussed in personalization and other areas too. That's it from me. Bertie, if you had anything that you wanted to chip in for everybody?
That very well covered everything that we were going to talk about today.
Oh, thanks for listening to me. I sometimes go a bit overboard.
No, anytime, Ramsey. We're going to have you run a couple of these in the full hours, which we're all excited to hear about. If anybody has any questions, feel free to speak up now. Otherwise, I think that we can call this session to a close and say thank you all very much for being here. And we look forward to seeing you next week for the last of our foundation series, and also the announcement of our competition, where you can get access to your first free version of the Workbench. So that will be next week. We look forward to seeing you guys then.
And thanks, everybody.
Thanks, everyone. Thank you. Bye.